I took up the challenge from JT Shred to make this shredder blade. These are my parameters. I'm using 20.1 or 0.20.1. This is what JT is trying to make. It's some kind of shredder blade. This is what it finally looks like, what I was able to make with it. And the interim stage of all this is this drawing, and we'll show you the rest of it now. So here's the design for the fourth time. Let's see, for the win, if I can get this down without having to get burrowed into all kinds of FreeCAD intricacies that hold you up from having success. So I'm going to create a new file here, save it immediately. Let's make it for the win. This is the money shoot, the money shot now. Shredder blade for JT, okay? Part, body, sketch. We'll draw flat here. What we're going to do is create our spoke pattern. We're going to create two of these. They're going to be somewhat similar. I'm going to hook them all together at the center here. We'll make them all of equal size. And we're going to set up the angle relationship between them. As we can actually put it in there as 360 over 5. 360 degrees by 5 blades. I'm just going to type in 72 here. It doesn't get remembered as the formula that you put in there. Something did not go right. What happened here? If you double click on the measurement, it doesn't remember it was 360 divided by 5. It just remembers the value. Okay, while I'm at it, done this a few times now. I'm going to create another one. Okay, exactly the same way. Also just grab them like that. All right, try that one more time. And there you have it. This is why it takes so much time. I went off script here, and it didn't work. I have a very sensitive mouse button, so that's why sometimes it glitches. Make them all equal. Do the same thing here. I'm going to set up a 72-degree relationship. Get it? Now the reason why I only have to do 4 is the fifth one. Once you've determined 4 out of 5, the fifth is constrained to 72 degrees. It can't be anything but 72 degrees. Okay, so we're going to drop this one in early, drop this one in on top of that. Okay, now this, hopefully it moves. It moves. I'm going to move this out of the way. Till we need it. I'll bring it back in again. I'm just so used to doing this that I know I'm going to need 2 of these. So what we're going to do is, if you look at JT's drawing, it looks like there's a center hub with 5 shark fins coming off of it. Okay. So we're going to draw a reference circle from the center. Okay. We'll give that a circumference. I think it was about 6 inches. Okay, so that's now giving us a relationship to the size. Okay. Actually, I don't like moving this over. I like clicking where I want the overlay to be and making sure that this is now connected in the center. Okay, so I'm going to make this a reference line. And the way that you do that is you select it and come up here and make it a construction line. I said the word reference. It should be construction. So construction doesn't get counted in toward any open frameworks that you might be, or any open wireframes that you're making here in the sketch mode. I do believe it will lead to an error later on that will delete it before, or we'll delete it at one of the last stages before we go to do a pad on this. Okay, so the way that this works is if you look at JT's drawing, if you look at it, you're going to have, I'm going to use one circle to explain it to begin with here, okay? So we have a circle just about the same diameter, and I want to try it right now and make it the same. So this and this, we're going to make the same size. Okay, so they're both 6 inches. I believe sometimes when I've seen designs like this, they try not, so it ends up being that you use the same sort of geometry scales over and over again. So they'll use the center circle as offset circles. We're going to have 5 offset circles, one at the end, at the tip of each of these spokes as they go around. And what you can see here is the beginning of the shark fin. It's going to come up, and then we're going to put another circle down here, and we're going to put a line up to this, join it up to this. So we're going to get that shredder tooth. We're going to get a shredder tooth. We have to put shredder tooths in here. And then we'll delete everything else of this circle. That's why it looks really busy. When we get to the point where we have 5 of these on here, you have to start remembering where you are with this. Excuse me. So, okay, so I'm going to draw, I need 4 more circles like this. 1, 2, 3, 4. I'm going to grab all 5 of these and make them the same size. And when you do this a number of times like I have, it starts getting more organized. And we're just going to attach the circle to the end of each spoke. This one and this one. This one. This one. And the 5th one. Okay. Center that in our picture here. Okay, so we centered it. Okay, so we're going to make some adjustments to those. Move that out of the way. Can I move it? There we go. I just want to move that up here out of the way a little bit. I'm going to drop that in a second. Okay, let's zoom in on this. So now we haven't specified how long these spokes are, okay? So you have to pick one circle and focus on it and get it down to a size where it seems like the shark fin is about the right size. All right, so I picked to watch this one here, and it's going to come up. And if you look at JT's picture, the arc of the shark fin is still expanding away from the center here at the point it cuts back in. Okay, so this blue circle is our reference. We're going to put a smaller circle here with a straight edge to make a point on the shark fin. I believe I have the diameters relatively correct with what I have here right now, okay? So what I want to do is I want to lock this in. I'm going to give the dimensions. Now remember we said that all of these are going to be equal. You put the constraint that they're all equal. So now I am going to let it tell me how long that is. I'm not going to put a number in there. I'm going to say, let it tell me how long that is. So we're going to look at constrain a distance, okay? And it's telling me it's 0.4707. So why might clean that number up a little bit by making it 0.47, which barely even made a difference. I didn't see much move on that. Okay. So I'd like to just make a round number if I can. I just took what it said. Okay, so here's that number, 407. Okay. And that gives me by eye kind of the size of the shark fin. Okay, now we need these little circles up here to form a sketch. All right. So again, I'm going to use this one here. All right, and it starts coming up. It starts becoming tangent to the inner circle about here. It's like apex, I think, like the highest point away from that inner circle is out here. We need to be back here because if you look at the picture from JT, that curve is still expanding out from the center. So we need to be somewhere in this range here. And his had about an inch along the perimeter of the core hub, about an inch before the next shark fin started. Here's the start of the next shark fin, if you will. Okay, so let's go back to our shark fin here. So we're going to need a circle in here. That's a little bit bigger than we need. Okay, so let me shrink this down. Oops. Let's make that smaller. Okay, and we're going to use that as part of the shape. See, it's going to come a tooth. The pointy end of the blade. This arc is going to end right here. Anything to the right is going to be deleted later on, and it's going to have a straight edge from this little circle up here, and the little circle is we're going to sit it down on our hub circle, the 6-inch hub circle. We're going to make it tangent to that. Okay, so that's where this comes in. We're going to bring this guy in. All right, and I'm going to sit him down. So I'm going to pick his center vertex, and we're going to center it with this. Now it's going to get a little bit crazy. Before I do that, whoops. I hit escape and it kicked me out. I have to go back into the edit mode. Okay, so we're back in the edit mode here. Okay, it actually starts getting visually a little bit crazy, but I want this longer so we can differentiate the two. They're too close to the same size. All right, so I click the vertex, and we're going to plop that down on there. Okay, now this should rotate. Okay, so this should rotate, and this should still rotate. So all those large circles that have their centers on the ends of these spokes are still, there's no constraint on any angle particular to the overall picture that we have here. They're both still rotating, and I'll show you why that's a little bit important. I think I came up with something that works here. All right, so I'm going to move up here. Okay, I'm going to look at that circle. What we have to do is find where this cutter, all right, this part of that shape makes the most sense. And what I'm doing is I'm looking at this angle of the circle I'm interested in. I've got to form a point here using this circle. We're going to form this blade point here, okay? So I can tell already that where I'm going, this has to be a little bit bigger. We're getting out. And what I'm looking at is if this ended up being the point, let's just say, the next shark fin is starting off the hub right here. Okay, and again, we're going to delete everything to the left. This is left is going to get deleted. So a lot of any of the lines that are interior to this 6-inch circle are going to get deleted. All right. So I have a really rough estimate of where this circle should be, and getting to approximately the diameter it should be. And what I'm going to do is now bring this guy up. All right, and we're going to set the little circles at the end of the long spokes. Okay, now what I came to look at here, let's look at this. if you watch as I rotate this, if we wanted to simplify all our numbers, okay, long spokes are probably going to end up half of 72 degrees. They're going to end up, long spokes are going to end up between the short spokes. If you look at the relation here, here's a short spoke, here's a short spoke, here's a long spoke. And unless we want to get crazy, I bet anything, I bet you the blade maker, the shredder blade maker, probably used 36 degrees. They probably will work. It might be a little bit less, but I'm going to go, if you actually go back and measure, I bet anything they use 36 degrees. Like everything's nicely, evenly spaced, uniformly spaced around the center by 36 degrees now. So what we're doing is we're getting a relation of where the small circles are with the large circles. And it happens to be, say, 36 degrees. So what we're going to do is I'm going to take long spoke, short spoke, make it half of 72. It ends up right in between them, okay? So now when we move them, everything's moving. Short and long spokes are rotating, okay? Now what I'm going to do is I'm going to sit this circle down on, this little shape circle down on the hub circle. And what we do is we're going to click that and we're going to put it on a tangent. So it drops it down and you can see the little tangent constraint popped open there. Okay, so we're going to move it over there. And we're going to plop these together. I think. Let's try that again. Didn't work. I might have unselected them. Okay, why is it not working? Control Z. You know what? It has to do. Let's try to make this a little bit smaller. Not much. I've been through this before, so I think it's going to be something on the order of that size, and I'm going to lock that size down. Whatever it is, it says 3038. I wonder if we just make it 0.3. If that's something that we can live with. I'm just hunting for maybe a rounder number. Yeah, I mean that's so little difference. So we now have a nice round number, 3/10 of an inch. Okay, all right. And somewhere along the line, I think there was a delay, and it finally caught up, and our circle is sitting on the end of the long spoke, and it's constrained. Everything's really kind of nicely constrained now. Okay, all right. So now let's drop in 4 more of these mini circles. We're going to make them all the same size. Those equal. And we're going to drop these down on the long spokes. Now I'm going to do something here that I found interesting. Now you can't depend that the system knows that this small circle is tangent to this. Notice there's a tangent constraint on this one, so you have to go back and you have to formally tangentize it. And I don't know why. I mean, other people that have more experience can say more about this, but it didn't put the symbol there. I ran into this when I was doing this yesterday. Might have put it up there. Yeah, I believe it put it up here. So it's grouping, what's it doing? It's actually grouping the constraints together visually. Okay, so we'll take one of these, drop it over here, and remember to make them tangent, because it won't close the wire and you're going to get one of those open wire errors. Okay, that looks good. Bring it down. Might have to pull back a little bit here. Drop him on that and make them tangent. Got that, tangent. Get our last one. Set her down. Nope. Over constrained. Control Z. Okay. Sometimes when I just try this again. Okay, see, it got constrained on there. It accidentally got It assumed or auto input a constraint that we don't want. I need to get rid of that. It sat that circle's center on the axis, and that's something I will bring up as a big point. I'm taking a second here to talk about that. That's what I'm watching out for. I'm watching out for bad behavior where the system automatically assigns a constraint you didn't have in mind or didn't intend to have in mind on that. That's what held me back from getting this done quicker, is getting used to that. So this exercise was good for me because you learn a lot of the idiosyncrasies. Now look at that, it went green. I wasn't even driving for that, but we went all green on this. The thing is fully constrained. I wasn't really shooting for that. And something to appreciate. I'm gonna do a Control S on here to save that, and let's take a walk back and see what it looks like. There we have it. All right. Okay, so now we have to add in some segments off the small circles to the large circles to form the point of the blade. If you look at the handheld one JT had, you can see that it doesn't come off as a tangent. It doesn't approach this tangentially because your point would be so fine that it would snap off unless you're cutting marshmallows, all right? So something like that. Okay, so this is where we're going to go with this. All right, now this is a forewarning that this intersection of the two large circles got to be interference for me when I did this the first time. What I'm going to do, and this might help, is I'm going to come over here and select multiple. Okay, so there's a lot of little ants all over my display right now, all these little constraints in here. So let's just not look at them. What you do for a while, all right, I'm going to turn just those constraints off. And if you click geometric, it knocks off all of the constraints and it will just leave dimensions up there, theoretically. Okay. Okay, there we go. Restrict visibility. Okay. So they're there effectively, but the way that I selected them, just these other dimensions are left. If we need to look at them, we can show them again. All right, so now I need to draw a line that's tangent to this line, to that circle rather, and it comes in some kind of angle to the circle. All right, so I said this line needs to be tangent on that circle. That forms that nice curve. See the tooth forming here? So we have a little tooth form there, okay? And I'm not sure, but maybe it was more like something like that, okay? And what I'm going to do is lock that, whatever the length is the one I want. So I'm going to go in here and give it a dimension, and it's telling me it is, let's go again with 0.3. It's very close to 0.3, 0.978. All right. And the reason I do that again is just to give us some round numbers. It doesn't have 4 digits of some strange relationship there. Okay, I think we've got everything. We've got our tangent there. We've got a distance. Okay, so now I'm going to go through and put the other 4 on, the other 4 segments. So I'm almost done. I mean, but it takes time. From here on out, it takes just time cleaning this up. You have to make sure the design is closed, but you're just going to, it's so much repetition. Once you get a handle of the geometries on there, okay, so I'm going to take my little extra line and make it tangent on there. Ooh, doesn't like that. Sometimes when it does that, okay, so I hit escape, I have to come back and edit. All right, Control Z. Let's undo that constraint. Let's do it again. I might have picked the wrong things that have been selected here. That. Okay, let's try the tangent. It doesn't like that. Not sure why. Let's take a look at why that is. What's going on here? Is this really on the circle? It's attached. It's attached. Oh, well, it already has tangent on there. I think it might have understood that. It automatically put it in there, but that's an extra one. There we go. It only needs to be tangent. What I just deleted was it had not only the tangent constraint, but it had a redundant, hey, that vertex is on the circle. So you can't be tangent without being on the circle. I just deleted that. It normally automatically deletes that for you, okay? See what happens is if I do it at the right angle, it'll automatically make it tangent. And it did. It not only added in tangent, but it's adding in that redundant, and that's what gives us troubles. You only need one of these. It should be auto-deleting that, but it's not. Delete. So there you go with FreeCAD. I don't know if it's part of a legit design process or not, but it doesn't seem like it to me. But boy, there's just so much going on under the covers here that the fact that it works at all makes me happy. Okay, let's put this is really kind of like the blade edge, the tip of the blade. Again, I'm picking a point so that it automatically puts that in there. And once again, it put the redundant number in there. I don't know why that tangent's there. Why is that tangent there? Oh. Seems right to me. Seems fine. Okay. I think we have one more to go. Put the tooth on it. Okay, here we go. Once again, I don't know why it's putting those in there. Delete. Okay. Did we sit that down on there? I believe we did. I believe this. Well, anyway, I don't know. Okay. We'll tell immediately if the wire is closed or not. Okay, so now what we have to do is make, if you remember the first one of these, we set at a certain size. So I'm going to make them all equal. So go around and pick them all up here. Click on them. Now, if all of these points got coincident like they're supposed to be, we're done with the geometries. Okay, let's take a picture. Let's take a walk back and see where we are with that. So there we have it. Okay. Now I'm just kind of using logic. It's hard to pick out by my eye what's going on here. But now we just start snipping. Okay, so we should start snipping. Now I am going to close that. And the reason is I'm going to copy this. I want to save a copy of this. And work on the copy. All right, I'm going to put this back under the body and turn that one off. So what I did is I hit space. I hit the original. So I'm going to change that name to, let's talk about our master sketch. It's something like a master sketch. And this will name our working sketch in case we have to go back. Ask me why I do that. So many things that go on here in FreeCAD. All right. Okay, so I'm going to go into the working sketch. Make sure that one's not shown. Go to the working sketch. All right, if you notice, we missed over here. Aha, that got onto the wrong place. Interesting, that had attached itself to the wrong spot. So these are the things you have to watch out for if things didn't go exactly the way you wanted them to go. So I'm just going to delete that and redo it. So we're going to put in a new line here. Come over to this. I was out far enough that it didn't take. It took to the wrong circle. It went on a large circle rather than a small circle. Tangent ties that and pick up that and that and make them equal. And to be consistent, oh, it went orange. You know why it went orange is because I was just going in to fix this part of it. It says it's on there. It says it's vertical. What's that? It tried to make this segment vertical. See, it's throwing in these extra constraints that don't belong there. Select it, delete it. All right. So see, the system tried to make that a vertical line. I didn't want that to be a vertical line. Got rid of that. All right. So that's why it got over constrained. There was some like conflicting constraints there. You might as well see the ugliness of what's going on here, right? Make them equal. I mean, this is what you run into. Control save. Okay. So now if our lines are correct, we should be able to just go in and snip things out of here and create the picture that we want. Now it should be still free to rotate, which no, it doesn't want to rotate. That is not a good sign because there was nothing that said there was a relative angle of any of this to any particular other thing that was permanent on here. Close. Right? Why this technically should be able to rotate. It's not. All right, we'll take it where it is and we'll live with it. Now let's see how our stitching goes. We might have to do some surgery on this. Let's go back over here and we're going to shut, I think that's the one. Back in here. It was showing, yeah, I just hid. There was an axis shown there. The plane was shown there. All right. So let's see if we can delete things. So we don't need this piece here. Okay, we're going to come up here and get our shears out, and we're going to clip that. So far, so good. That works. See, notice that big part of the circle is gone. All right. And so if everything works right, we can clip that. There's our tooth, everybody. That's what you were living for. Okay. So I don't know what we are, half an hour into a discussion, and now you can see the first tooth emerging, but we're not quite done there. Okay, so what else don't we need here? So if you notice, what I'm going to do is escape out of this. I'm going to grab our major circle there, and I'm going to go back to making it non-referenced. This is an actual part of our design now, okay? Because I need to clip some things here. So what am I going to clip? All right, so something's flying over here. Let's get rid of this. I'll try to clean up enough that it starts revealing itself. Where was the main circle? This is the main circle here. Okay, the main circle is the one where the little circles are sitting on top of it. Okay, so anything on the inside can go. Anything below that circle. Look at all these that I'm getting rid of. These are all inside. This is the major circle here, the hub circle. Okay, we don't want to delete too much of that yet. All right, so I can get rid of this. Should be fine. Something's going on over here. I better watch out for it. I'm safe to delete anything on the inside of the hub circle. Hub circle. What we're doing here. That can go. There's a little piece left up in here we have to get rid of. All right. There you have it. I mean, if you want to keep watching, I'm going to clean this all up. This guy doesn't want to be here. The easy parts are anything that falls inside the major hub circle. Oops. Go back. I fell off I dropped my clippers. Okay, so we're cleaning quite a bit up. This can go. Seems to me. This can go. This can go. Where's the circle? Is that the circle? No. Get rid of that. That. Don't go too crazy too fast. Get rid of that. Give me another tooth. Let's take care of our teeth. Do some dentistry here. Okay, we have all these teeth. Now I know there's a remnant hiding in here. Get rid of that guy. Get rid of all these too. Look at all these things we're getting rid of. Concentrating on the fact that this is our main circle here and keeping that in mind. This can go. It's gone. This is fairly clean. It's working fairly well. Haven't had any disasters yet. Okay, let's take a look back. Step back, and it's pretty clean. Okay, get rid of this. Okay, here comes the scary part. Going to get rid of our little spokes here. Get rid of all those. We were just using them for locating things. Okay, we're almost there. We just need to get rid of that, 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 that. And there you have a blade. Now, if everything works, our vertices are all tied in together. And this looks pretty much like the outline of the blade. Now you play with the geometries. You can make the circles a little bit bigger to make your teeth larger. You can change the length of the flat spot that goes out to the tip to make that right. But this is basically it. All right. Control save. Save that away. Okay. Anybody queasy about? Let's take a look at doing a pad. Let's do a pad. Let's make it an inch thick blade. Okay. So somewhere when you get a wire is not closed, not the end of the world. We're going to cancel out of this. We go back in and we're going to edit this. We have to go in and now we have to find, there's like a remnant of a line left that we didn't catch, or what you can do is kind of just see, Control C. Okay, so seriously, 2 hours later, I had a problem where the validate sketch command is found in both the Sketcher WorkBench and the Part Design WorkBench, and the one in the Part Design WorkBench wasn't giving me what I needed. I didn't know that there were two of them. So, running out to YouTube and finding a couple of videos and figuring this thing out and making a correction and finding the problem on these on my sketch here. Everything is right now. It's held in accurately to everything that we've done. If you roll back a few minutes toward the point where I started having the wire is not closed error, if you look at the screen, you're going to see that there were some constraints on a few of these vertices here. And from 3 miles out, they look like that they are coincident. But if you go in really closely, you'll find out. And when I say closely, I mean you're going in with a microscope. You have to go way, way down in there to find out that these are missing each other. So I don't know. I think FreeCAD could help out a little bit more and show that maybe a color when these things are actually joined and versus two overlaid vertices at 3 miles out like this that aren't really connected. I've run into this very same problem with almost every other package I've used. I was using SketchUp, Fusion 360, and whenever you get down to nitty gritty, doing what we just did was we went through there bushwhacking, pulling out all these segments. FreeCAD had a little bit of problem. But here's the thing. It took me about 2 hours to figure out, but it took me about 10 minutes to fix. Okay. So that's the big message. When you're in Sketcher, if you notice, I'm actually editing the sketch right now, and this has been healed. Okay. So I healed this. And what I did was in your Sketcher workbench, come up to the sketch and run a validate sketch on it. Like so. Oh, actually, I think I have to get out of here. Okay, so let's close out of this. And I think you run it. I named my drawing Buzzsaw. I was getting kind of punch drunk when I was working on this. So the Buzzsaw blade here, I should really name it the Buzzsaw blade. What's the name of the blade? It's a good name for this. The Buzzsaw blade. I guess maybe you're here. Let's go to Sketcher. Go to the Sketcher workbench. And then when you go in here and try to validate sketch, it's now live. It wasn't alive when I was actually editing this, so you have to not be in editing, okay? All right. And so the very first thing, this is an added feature when you're in a Sketcher workbench that's not in the part design, all right? So if you click highlight troublesome vertices, you won't, well, I say vertexes. I'm just going to tell you that it's vertices is proper. I don't know, maybe that's another way to spell it. But anyway, everything's cured here, but what happened is on about 6 of these nodes, error. Very faintly you could see that it was highlighting it, and you kind of have to zoom in to see what the problem was. And in a couple of these, there were tip-offs. If you go back a few slides, slides, right? If you go back a few minutes at the end of when I was having the problem, you'll notice that there were some constraints listed for some of these that didn't actually make pure sense. So I had to go in there, and I'm not going to make a whole long video about what the signals are that there was something wrong. But I noticed that two of these vertices, overlaid vertices, were fine. There were no constraints. And then on the other 3 that there were constraints. I'm like, that's kind of interesting. They should all be the same. I was trying to make everything consistent. They should be the same. And sure enough, I had to go in there, and instead of being the vertices being coincident with each other, one of the vertices was actually constrained onto the other segment. It was like an overlap. And so once I deleted the constraint, that freed them up, and I could pull them apart by like a micron of a micron, and then select both of them and tell them to be coincident. And so at the micron level, the dimensions here at this vertices and this vertices and a couple of these other vertices, like right there, and that one there, and that one. These are the ones that I remembered I had to go in and fix. If you go in and you look at them, when I went in and looked at them, I had to move them. I'm looking like an order of a micron, so they're slightly, it's impure. It's not pure. The design is impure, but you could go to market with it. Let's put it that way. It's that accurate. So that's where 2 hours were spent getting this. Now let me close this out. Okay, now that it's been healed, I'm going to go back into the part design workbench. Come over here. I still have the buzzsaw blade selected, and we're going to do, now we can do the extrude or pad. Okay, so and as soon as I click it and I hit enter, it's 10 millimeters thick, is 3937. A millimeter is 0.03937. So it's what I say, 10 millimeters thick. And if we take a look at it, yeah, it's vaguely. And so that's how you can make it thick. You can now, that's the end of it. but it's not the end of it. I mean, if you were really going to design it, you'd start putting bevels and chamfers and different things on edges here. I mean, you wouldn't make it this thick, right? You'd come in here and figure out it's probably 1/8 of an inch. So if I go in here and edit this to be 1/8 of an inch thick, 125. Okay, something more, more reasonable for a blade like that. You could technically get this thing to work. However you want to make the sharp point on here. Anyway, so that's all done. Hopefully that helped. A little bit long-winded, but I had to learn something in here as well. When you do a lot of this editing and deletion of all this web of superfluous, redundant lines in the sketch like that, you're going to end up with problems, and your friend is going to be running over to the sketcher and go under the sketch, validate sketch area. Okay, so that will take care of that. Well, I hope that helps. Very interesting. I love these challenges. It made me a better FreeCAD person right now. It actually worked out pretty well. Take it from there.